this video tutorial. My name is Kyle. I am currently a Senior Information and Computer Technology major at East Carolina University. I have developed the following tutorial as a part of my senior capstone project and hope that it enhances your understanding of Linux concepts.
In this tutorial, we will be covering how to install and configure NFS, a network file system. A NFS allows for centralized file management, as a NFS is a file system that is available and mountable over a network. A NFS can be mounted to interact with local file systems or other network file systems. NFS by default listens on TCP port 2049. To begin this tutorial, we must remember that the port map service must be running to run an NFS server. To verify that port map is active, utilize the following command: service port map status. As we can see, our port map service was actually stopped, so we should definitely turn it on if we wish to configure NFS with service port map start. Next, we'll want to start the NFS service with service NFS start. And we'll also want to ensure that NFS will be started on boot time by issuing checkconfig NFS on. In this tutorial, we will be covering how to configure the NFS server by manually editing the /etc/exports file and by using the exportfs command. Although not covered in this tutorial, the NFS server can also be configured by using the GUI-based NFS server configuration tool. First, let's export via /etc/exports. Editing the /etc/exports file is fairly straightforward. This file controls what directories our NFS server will export. Let's go ahead and export our example. Add the following to your /etc/exports file: /share/myredhat, 3 spaces, redhat.foo.org, open parentheses, rw, sync, close parentheses. With this example, we have allowed users to mount our /share/myredhat directory with read-write privileges in synchronized mode. But what if our hostname is an IP address? That's easy. Simply replace redhat.foo.org with the IP of the host. In this case, 192.168.2.106/24, where /24 denotes our network mask 255.255.255.0. The net mask can also be written out. Since we simply need redhat.foo.org, let's remove our 192.168.2.106 shares. Next, let's implement our changes by using the service NFS reload command. Next, let's export our previous example using the exportfs command. The exportfs command basically is a culmination of /etc/exports edits. When the exportfs command is used, it exports the directories we specify using NFS in one simple command. The exportfs command, when used without arguments, cues the NFS server to display all currently exported directories. Let's use the exportfs command to export our above example. Simply type the following command: exportfs -o rw, sync redhat.foo.org /share/myredhat. That's it. Now reload the service with service NFS reload. Next, let's check if our NFS share was exported. Utilize the exportfs command with no arguments. We can see that our share was exported. Next, let's configure our NFS client. The NFS client can mount the NFS shares by utilizing either the mount command, placing the mounts within the /etc/fstab configuration file, or by utilizing an auto mounter. Let's mount a NFS share using the mount command. In this example, we've mounted an NFS share with mount-t NFS with read-write permissions in synchronize mode, -O for options, RW, sync. The share we are attempting to access is at the redhat.foo.org domain under /share/myredhat. We've decided we want to locally mount the share at /myredhat. So now that we've mounted the share, we should be able to utilize the mount command with no arguments to see the share. Next, let's make this mount persistent at boot time by placing it in /etc/fstab. Place the following at the end of your /etc/fstab file: redhat.foo.org/share/myredhat NFS RW, sync 0 When doing this, make sure to stay underneath the columns represented in the /etc/fstab file. The third way of mounting NFS shares is through an auto mounter. I suggest you check out the auto mounter tutorial for a detailed look at how to mount an NFS share with the AutoFS service. In the next part of this tutorial, we will be covering how to install, configure, and utilize Samba. Samba is a service that assists Linux in connecting with a variety of Windows-based services and allows network browsing, Windows authentication, and has the ability to serve directory trees to Windows and Unix clients from Linux systems. The Samba application requires a few packages. Let's go ahead and install them. The packages are Samba, Samba-common, and Samba-client. Once Yum has finished installing our packages, simply start the service with service smb start. As with NFS, Samba can be configured with the GUI-based Samba server configuration tool. However, this tutorial only covers the command line configuration. Samba's configuration file is /etc/samba/smb.conf. Let's edit this configuration file to use our example Windows share. First, we need to edit the workgroup name and add a server string. Our workgroup name is the workgroup name that our Windows shares are available in. In this example, it is workgroup. Next, specify a server string, which is simply a comment about our server. Let's use my Windows shares. Next, scroll to the bottom of the Samba config. We need to create a Samba share directory for our file system. Let's name our share Windows, have a comment of Windows files, and have our share path /home/share. Let's make the share public and read writable with writable equals yes. We don't need print support, so we'll have printable equals no. And we need user support, so let's add Kyle.Squizzato as a valid user. Because we've added Kyle.Squizzato as a valid user for our share, we need to give that user a password. Utilize the smb password command to do so, with smb pass wd-a Kyle.Squizzato. Then input password1 as the password. As with NFS, Samba utilizes a client-server model. You can simply connect to the Samba share or mount it so it can be treated as local. We can view Samba shares available on our network by opening the Nautilus file browser and selecting Windows Network from the network browser under Computer. Or you can access the Samba share by entering the smb URL in the browser location field. Choosing a share often prompts an authentication window. To connect to a Samba share via the SMB client, we must first query our network in search of Samba servers. Let's utilize the find SMB command to output a list of Samba servers on our network. Here's our Samba share we want to connect to. Now, let's use the SMB client command to connect to the share. Here we've connected to our localhost/Windows share. For -u, we must input our username, in this case, Kyle.Squizzato. This is the way we authenticate when we're using the command line. SMB client will then prompt for a password. Once the SMB:/ prompt is visible, we've logged into the share. If we want our Samba share to be treated as a local file system, we must mount it. To mount a Samba share, utilize the mount-t /sys type. For options, we need to specify our user and password with -o user equals Kyle.Squizzato, comma, password equals password1. To review the NFS portion of the tutorial, we created an NFS server. Always make sure to check to see if port map is running, and if not, make sure to start the service, as the port map service is required by NFS. After checking our port map status, we utilized both the /etc/exports file and exportfs command to export our example. I'd like to note that you should make sure not to add spaces between your options in both the /etc/exports file and when using the exportfs command. Once the command has been inputted or the file has been edited, you must reload the NFS service with service NFS reload or exportfs-r. We can view our exported shares with the exportfs command. Next, we mounted our NFS share and made it persistent in /etc/fstab. To review the Samba portion of this tutorial, we created a Samba share and then connected to it. We started by installing the required Samba packages. Then we configured our workgroup and server string, and then went to create a Windows share, which was public, had writable permissions, and was non-printable. We then gave Kyle.Squizzato access to the share by granting his account a password with the Samba password command. Once Kyle.Squizzato had access, we logged into Samba through Nautilus and through the SMB client. Finally, we mounted our Samba share so we could use it locally.